Good afternoon, and thank you for joining today's Protecting Data in Azure, AWS and Applications webinar. My name is Michael Holden from Bytes. I'm pleased to be joined today by Lawrence Nutt, Channel Sales Manager, and Manoj Bhatti, Senior Technical Consultant from Thales, who will be taking us through the bulk of today's presentation. Before that, just some quick housekeeping. Attendee lines will be on mute throughout the session. There will be a Q&A at the end, so please post any questions in the questions window, and they will be fielded during this Q&A. This is a purely strategic discussion, so any commercials can be discussed with your Bytes account manager after the session. Everyone will receive the recording after the session. And lastly, we have a feedback survey at the end of this presentation, and would appreciate it if you could take 2 minutes to complete it, as we use these to make sure that our webinars are still hitting the mark. So, the agenda for the day. So firstly, a short overview of Bytes. We will then move into the majority of the presentation from Lawrence and Manoj, where they will go over how to ensure optimal data protection for Microsoft Azure, how to bring your own encryption to the public cloud, circumventing common SaaS data security failings, and securing access to cloud assets and applications from any device and location, which will then be followed by our Q&A. And so, who are Bytes? Bytes enable effective and cost-efficient technology sourcing, adoption, security, and management of software, hardware, and cloud services. Bytes have a wide range of expertise, including licensing and SAM, data management, and security. On the security side, we have a wide range of technology partners with the highest level of accreditations with the majority of our vendors. We offer a variety of technical services, hold multiple accreditations, and boast award-winning delivery, which we are extremely proud of. That's enough about us. Let's talk about protecting data. As mentioned previously, we are joined by Lawrence Nutt and Manoj Bhatti from Thales. Bytes are a Thales Premium Platinum partner, and Thales is a world leader in digital security. So who best to talk to you about protecting data in Azure, AWS, and Applications? With that, over to you, Lawrence.
Thanks very much, Michael. Good afternoon, everyone. I'll just wait for the slides to load. Excellent. Next slide, please, Manoj. Excellent. So to just sort of provide a bit of scene setting in terms of what we're going to discuss today, what is happening in the industry. Obviously there's a huge move to the cloud, and I think the fair thing to say about the cloud is it can be seen in any way. Everyone's got a slightly different view on what the cloud is, but I think one thing that no one denies is that it's growing, it's becoming more applicable given the current working environment for most people. But also it comes with new challenges, and those challenges revolve particularly around security, and the stats that you can see up on the slide at the moment, as you see at the bottom of the source. So Thales provide a data threat report annually that goes into a number of different areas, but a key focus is around cloud security. And as you can see here, it's now about 50% of organizations that are using the cloud and implementing some form of data protection within the cloud, but there's still a significant gap there. And I think that one of the key takeaways certainly that we'd like you to take from today is that businesses remain responsible for security of the data in the cloud, regardless of the provider, and hence why today we're talking around multiple platforms. And again, the key point here is the cloud providers provide the security of the infrastructure of the cloud. But in terms of what's put into that cloud, and again, whether that be Azure, AWS, or others, that data it's the responsibility of the organization to ensure that it's secure and that it's accessed by the right people, and that is maintained continually. But what you can also see as we drop down into the middle section is that businesses are really struggling with the complexity around the cloud and trying to put together sort of how to make use of the cloud whilst protecting that data and ensuring that they're adhering to their own internal regulations, but also any external compliance, and maintaining a high level of security. And again, as you can see from the stats here, there's still quite a gap between the fact that customers know that that there's a lot, perhaps a larger perceived risk in going to the cloud, and therefore they're careful around what they put in the cloud. And what Thales really look to enable is the ability to use the cloud as much as you like, and to be able to use it in a secure way. And again, as we go through today, hopefully what you'll start to see is some relatively simple steps that you can implement. And I think one of the key things, as you see at the bottom here, is a lot of businesses are using a lot of cloud applications. As you can see, it's 29, up from 27 in 2018. And some even have more than that, over 50. And I think one of the things we often find when we're talking to our customers is they'll be talking around one or two clouds, and then when you start to look at their entire environment, there's actually more cloud being used than not that then they realize, but because people perhaps don't see a platform as being cloud even when it is. And so again, we'll go through some of that today. Next slide, please, Manoj. So in terms of some of the simple high-level issues, if you like, that to be considered when looking at the cloud is the main thing is around data protection. And if you look, there's a number of breaches, and they happen on a fairly regular basis now, and they're mainstream news. Even just this year, there's been some fairly large and significant breaches. And again, if you look at it, the breaches tend to happen in slightly different ways. And there's always different reasons, whether it be external threats, internal threats, accidental, on purpose. But the key takeaways from any breach is, people always want to know how much data was taken. It's always around what was how many records were taken, how many credit card details, how many passport. It's that sort of information. That's the headline grabbers. And then the impact of those breaches, yes, there's a monetary value, and various fines can be applied if it's based under GDPR, etc. But again, beyond just the initial financial impact, there's in terms of that fine, there's the loss of reputation, the fines, but also the cost of rectifying that breach. And again, I think you can look at some fairly well-known examples where people have announced breaches, and the day they announce that, some organizations talk about losing a third of their share price. So again, whilst it's not always easy to put a cost on a breach, after a while you can soon start to see there's various aspects that make that up. And again, if you look at it from a headline perspective, it's often sort of the C-levels that are put in front of the news to explain what's happened, why it's happened, and what steps are being taken. But then even just at a sort of the if you like the IT level, looking at how do we do more in the cloud if that's the route we want to take. It's really trying to understand and move away from this idea of what we call at Thales these islands of security, where teams are putting in particular clouds and or new applications, and they're looking at it from effectively tunnel vision from their perspective, and they're not looking at the wider business piece around how do they utilize more of this as an organization. And again, some people feel that it's because this team are using Google and we want to use Azure, or this team's using AWS. And hopefully, again, what you'll see from today and Thales is that you're not limited by that. You can still have an enterprise-wide security suite that allows you to address these problems. And it's not just from Thales. Hopefully you'll find some takeaways outside of what Thales can provide. Because if you don't put in the various requirements that are needed around cloud security, we've talked, there's financial penalties, there's the loss of business, there's also potential legal action. So there's a number of issues beyond just as I say, a GDPR fine that should be considered. And Manoj, if you can jump to my final slide. So again, as we're going through, and as Manoj kind of really gets under the hood of things to consider, hopefully these are some key questions just to keep at the top of your mind as we're going through today. Again, relatively simple questions, but again, hopefully it just provides a bit of food for thought. So you see, how do you protect your data in terms of what steps have you put in place, what steps are you considering? If you have got applications in the cloud, again, how do you provide data protection around those applications? And again, if you have to provide access, how do you do that in a secure way? So again, hopefully, and I say, it doesn't have to be something from Thales. It's a general conversation to kind of think about as you're going through. So Manoj, over to you.
Thank you so much, Lawrence. Good afternoon, everyone. So today I'll take you through to the presentation, securing data in Azure, AWS, and any application with Thales. So before we start the presentation, I just wanted to know that do not forget to blink your eyes as many number of times as you may. Blink it 20 times, because normally when you're looking at the screen, it drops to 7. So it's good to know that if you blink your eyes more number of times, you'll be all right for next 20-25 minutes. Okay, so cloud has been an interesting topic for everyone around the world, around the globe for many years. Satya Nadella, CEO of Microsoft, came up with a statement saying they have seen 2 years worth of digital transformation in just 2 months. We knew because of all these circumstances. However, we said the same thing. If you remember, if you're following Bytes, different presentations that we have given at Bytes. So this is exactly the same information that we gave you 6 or more months ago, 9 months ago, in the same context. We always knew cloud has a potential. Cloud has the platform to allow anyone to grow quickly. Cloud has the performance to allow anyone to not only to grow quickly, but also to make sure that they are the performance is there as and when they need it. If they need more, you can increase. If you need less, you can simply switch off the resources and use less of it. And just because there's so much information residing in cloud, if you remember Lawrence's presentation, or not one of the Lawrence's slide deck, the 53% of the total organizations around the world are using cloud now. One of the important question is where exactly does the data reside in general when you're using when you're storing the data on premise and when you're storing the data in cloud. So if you look, this is all the different places the data resides. We have heard a lot of organizations, a lot of individuals, when they talk about data at rest, they simply mean data at the disks that they're storing. However, data at rest resides in all different places, as you can think of: application, databases, files and folders, hypervisors. Disk is the final place where it resides. However, it also resides in all these different places as well. It's all good and cute when the data is on-premise because you have everything. However, the moment you move into cloud, to multi-cloud, or to the hybrid cloud environment, you often lose control of where does your data reside, who has access to it, who is allowed to see the data, back up the data, and a lot of the other information. And this is why you might have seen the cloud when it comes to storing the data. It's amazing. However, when it comes to security, there is a basic security that the cloud provides. However, when the data is residing on cloud, the security of the data is always the organization's responsibility. Cloud has a shared security model. So anything that resides on cloud, they would provide you the basic level of security. However, the data security always is the customer's responsibility, anyone who's actually storing the data into the cloud. Now, remember all these different layers, and then now we ask you a very important question is, who do you think is responsible for data security in your organizations? So what we did is we went into LinkedIn, into lots of other platforms, and then we try to look for the job profiles. What are the top 5 job responsibilities of the job descriptions of the users that work in each one of these layers? At the application layer, we have programmers. At the database layers, we have the DBAs. At this, the operating system layers, we have the system administrators, the IT team. Then comes the hypervisor or the virtualization or the cloud administrator. And then if you are in on-premise, then come the storage administrators as well. So when we actually saw the job descriptions, the top 5 job responsibilities doesn't include security except database and application. When we try to look a little bit deeper, the security at the application level was more of a secure code rather than the data security. This is very important because when we speak to a lot of people in the organizations, a lot of different organizations, and we simply say, whose responsibility is the data security, and the answer comes as everyone's. Unfortunately, if it's not in their top 5 job description, the responsibilities, I'm sorry, then it is hard to understand how they are securing the data that they are using or have access to, or they have to administer or manage. So this is important to note. Now let's see what kind of security does the cloud provide, and we'll only compare 2. There are more. However, the 2 most popular cloud platforms is AWS and Azure. So if you are going into a multi-cloud or a hybrid model, you actually can see the solutions which are on 2 different cloud platforms are absolutely different. You cannot use the same platform to have the security, any type of security in the other cloud platform itself. When you speak to AWS, when you speak to Azure, they would want you to use everything native. Anything that they provide, anything that they can get the direct revenue. But is it the best security level? We have our doubts, because eventually what they're trying to do is to make sure that they ask you to use so many native applications that it becomes impossible for you to move out of the cloud. Not exactly it's secure, but it's more of you're tied into the cloud so much that it becomes impossible for you to get out. And then when you actually come to use any of the other security vendors, think of how many security vendors you actually work with. The answer could vary anywhere between 20, 40 to 200, depending upon how big you are as an organization. So it becomes really, really hard for anyone to not only choose the right security for the data, because often you talk to organizations, often you talk to individuals, often you talk to teams, they ask you to choose a tool. They forget about the proper cloud or the data security strategy. It's just the moment you decide upon a solution, then the last conversation is about the security most of the times. Someone says, oh, let's use this tool, and then you use this tool, and then you use some other solution, use some other tools, and then you end up making complete silos of security islands. This particular solution is used to secure this particular environment or this one particular application, and then you have a completely separate solution, separate administrators that provide the security to a completely different environment, different solutions altogether. So this is exactly the reason why you see so many different hacks that happen, because the data security has failed, or most of the organizations fail at the data security purely because they do not have a centralized data security approach. The approach that they have today, either it's not covering the entire gambit of different environments they have. You can very happily say we have the on-premise model only, and that's how we deal with our data security at the moment. That might not be true after 5 years. If you're using a hybrid model, then you would very soon see yourself using a multi-cloud model as well in next 5 years. And you already have a multi-cloud model. You already know the challenges that you get with a multi-cloud model. Is there's absolutely no single place where you can see or push the data security from. The other thing that we have seen, and this is one of the most common thing I briefly talked about, is security has more become a tool picking game. You would have the application or the DevOps team coming to you and deciding upon a tool with zero input most of the time. Sometimes they have security team on board by saying this is the tool of choice, and security team has to then say yes. DBAs, they have a completely different view of security. They would use or choose a completely different tool. The cloud administrators, Azure, AWS, Google, they would have a completely different set of tools. And the virtualization administrators, VMware, Hyper-V, they would have a completely different input. They all will choose separate tools without even thinking about the centralized security policies or the the single pane of glass kind of solutions. And then they themselves then becomes the security administrators of your organizations. So DevOps become a completely different security administrators. There should be DevOps. DBAs should be managing the databases. They then become not only the database administrators, but also the security administrators, because they know how security is being defined or configured in the databases. The cloud administrators become, not only the cloud administrator, someone who should be helping you in managing the cloud, the different applications, different resources that you have in the cloud, but they also then become the security administrators for you as well. And same is for the virtualization, storage, and we can go on. All these administrators not only become the management people or the management department, they also become the security department in themselves. And the last is, and this is common across almost 100% of the organizations that we have spoken to in the last 10 years. Every single time that we have asked, do you know where data is? And the answer is, we don't know. So how would you be able to protect something that you cannot see? You can't see, you can't protect. So what exactly is the Thales' approach? First step is the user authentication. It, as you know, when an organization, when you're coming into an organization via network or even physically, it's important to understand your user who's actually logging into an application, who's actually logging into a network, who's logging into an environment, becomes more important, because you would like to prove the identity to make sure someone who says he or she is the same person who's logging in using you in your environment itself. So at Thales, what we have done is we always had, for ages, we had the two-factor as an authentication platform or a service that we always provided our customers. We have our tokens, a wide range of tokens that we have. We have the hardware tokens, software tokens, we have the SMS-based tokens, we have the pattern-based tokens, which are browser-based. So you don't even have to give anyone a software or a hardware. It's just a browser-based token that you can use. So we have a huge number of tokens. We also have the push OTP. That simply means no one has to enter any OTP. The moment you try to log into, for example, Office 365, you see a push notification on your phone saying Office 365 is trying to access your token that probably installed on your phone, or your, on your iPhone, on your Android phone, or your Windows 10 machine, and you simply say allow, and then it uses the biometric authentication of fingerprints, Face ID. If none is available, then the PIN, anything that your phone supports for authentication. So not only that we have the device level security, you need to allow the access, but then we have the application level security as well, because unless you prove your authentication using fingerprint, Face ID, or the PIN, the OTP wouldn't be pushed from your phone onto the application itself. So it's an amazing user experience, and we can integrate with almost everything. So we have integrations with the Radius as a protocol. So anything Radius we can integrate with. OIDC, SAML 2.0, that simply means we cover almost all the cloud applications that provides either one of these protocol for second factor of authentication. There are a lot of different applications that you see on screen. However, our support for second factor of authentication is not limited to these applications. We then provide a generic template. If you don't see the name of the application that you're using on the screen now or on our platform, we give you a capability to use it as a generic wizard and just go through the steps depending upon if it's a SAML or a OIDC protocol that you're using on that particular application. However, we did not stop at the second factor of authentication. We then created a single sign-on solution a couple of years ago, and it's called SafeNet Trusted Access. So you have your huge number of authentication tokens that you see on the bottom left. Then you can add a lot of different contextual policies and on these devices. So for example, you can define what operating system you allow your tokens to be installed on or to make the communication. You can define saying Windows 7 is out of Microsoft support, so you will only support anything that's Windows 8 and up. You can also simply say the network which you have in your office is a secure network, so we only want user to put their username and password and nothing else. So it's a step down. The moment they go outside of the network, it's they have to provide username, password, and OTP. So it's a step up authentication. You can put the support for the user browsers or the anonymous networks called like Tor. You can simply say anyone trying to use anonymous networks, we do not want to allow any access to our applications using Tor browser. Or you can say, you know what, it's okay. However, the moment someone tries to access anything using anonymous networks, they have to not only provide the username, password, but OTP every single access attempt, not one for the whole session. And then, as I mentioned, it's a single sign-on. We have the feature where you authenticate yourself once, and then for next 8 hours, probably for next 2 hours, user defined. Every single other application that you click, it's automatically logged in. It is an amazing user experience from a user's perspective. They come in, they turn on their laptops, they log in to the resource for the first time using their username, password, and OTP, and then for the rest of the session, they just click on the resource. It could be any application, Salesforce, AWS, Office 365, anything, and it just simply logs on. Think of the productivity and the user experience. It's amazing. It's great user experience. The one thing that everyone forgets that the single sign-on brings is a single sign-off. If your user is accessing, not in today's time, but when your user goes outside and try to access any of the applications from outside of the office, for example, sitting in a Starbucks or sitting in Pret, trying to access the applications, the moment they log off, they log off from all the different applications. So it's single sign on and the single sign off, all of them. It's an amazing level of security. Then comes the centralized data security. You have authenticated the users based on the username, passwords, and OTP. And however, what would you do to have that centralized data security policies? So at Thales, we have the 4-point strategy. 1, discover the sensitive data. 2, protect the sensitive data. 3, control data and keys. And the 4, monitor data access. How are we providing this? We have a complete data security platform that allows you to discover, protect, control, and monitor everything. So what does the data security platform consist? So the data security platform consists of 2 major things. One is a CipherTrust manager that you see at the core of the circle here that you see on the screen. So CipherTrust manager, it's a key management solution. This key management solution, it's the KMS solution, or the key management solution. This KMS solution helps you to generate, create, backup, distribute, delete, rotate, renew all the keys in one centralized platform. It can be a hardware, it can be a virtual machine. It gives you the capability of storing all your keys in one single location. When you store the keys, it then allows you to use these keys in various different places, and this makes the entire data security platform. So using this CipherTrust Key Manager, you can protect or encrypt this all the different solutions that you see on the screen. It helps you in encrypting the applications. So we have our own set of APIs, so you can use our APIs and encrypt the data at the application level. So Java, .NET, REST, you can do anything from applications to databases. We have on the left-hand side, you can actually see there's a huge number of databases that we support, including Oracle and MS SQL TDE. So if you're using any one of these, if you're using TDE, you can simply offload the master key onto the CipherTrust Key Manager. And then all the other databases, they almost have a similar approach for the transparent data encryption. However, they use KMIP protocol to provide this kind of security to you, and the CipherTrust Key Manager supports KMIP as a platform. Other than that, we have a huge integrations with all the different solutions, including VMware vSphere. So VMware vSphere 6.5 and above, it started to provide encryption of the virtual machines as well as the vSANs. We have a huge number of customers who are using this platform to encrypt their virtual machines and vSANs as well. So, we have similar integrations with NetApp, Dell, EMC, so Dell component self-encrypting drives, DataStax, MongoDB that you see. There's a lot of other integrations that we have, and then we can integrate with any solution that is KMIP 1.2 and above, that supports KMIP 1.2 or KMIP 2.0. The similar solution then helps you in cloud as well. In the cloud, I will show you next few slides how do we actually protect your data and your keys when you move into the cloud. So what are the reasons or what are the advantages of using the CipherTrust Manager? It's one unified console that allows you to have the data discovery as a platform from within itself. So you using the same CipherTrust Key Manager, you can not only encrypt the data, you can also discover the data, classify the data where it resides. So you can run agentless or agent-based scan on your system. Then you can define or classify the data based on GDPR, HIPAA, SOX compliances, PII data. You can say, passport information, financial data, credit card numbers, all the different type of information that you're storing in your network, and then comes up with the scan and say these are all the different places. Once you know the places, you can then protect, encrypt the data, or at least it will allow you to have that knowledge that these are all the different places. This is where the data resides. This then becomes a tool to then show to business saying, look, we ran a scan. These are all the different places our data resides, and then we have the technology. If we need more finances, more resources, this is exactly the solution that you would like to have, so that you can have better, you can plan better, not only for security, but if you need resources or finances, you can show the report to the business, and you can have those. At least it'll serve as a base. It has a self-service licensing, so you can log on to our to our platform, and then you can define how many licenses that you would want, how many licenses to use. You can develop, it supports REST API, so you can either create your own GUI interface, or it already has a GUI interface. It works with every cloud platform. You'll see in the next couple of slides. It supports multi-tenancy. That simply means you as an organization can create a centralized role, and however, the moment any project, any department wants to have or wants to use the CipherTrust manager capabilities for storing the keys, for using the encryption, you can give them a tenant account onto that CipherTrust manager. So that particular department then becomes a complete administrator of that part. However, you have the complete control as an organization of the keys. You know where the keys are, where you have to go to change the keys, rotate the keys, renew the keys, everything. And then, as I mentioned, our product is available in virtual as well as the hardware platform. You have an option of going all virtual, or simply saying, I have a hardware platform. I need FIPS 140-2 level 3 compliant platform. So we give you the hardware. So this is all good. However, how do we fit into a network? You actually can see we have a lot of different solutions. This is a sample architecture diagram. This is how we see we fit into the network. In the middle there, you can actually let's see from the top. On the top, this is a 3-layer approach. On the top, you actually see these are all the different places where your data sits. So we help you in encrypting the data in all these different places. This is not limited to these, but we have a lot of different places where we can help you in encrypting the data. So that's the place where we are encrypting the data using all different solutions. Key manager, this is the second layer. This is where we are storing all the keys that you're using for data encryption on all the platforms above. This is centralized key management. You can do come here for key rotation, key management, deletion of the keys, and then the root of trust of this key manager then resides on our HSM solutions. These HSM solutions can further be used to support your PKI infrastructure. So if you have the root CA, the sub CAs, you can store the private keys of your root CAs and the sub CAs onto the HSMs, and you can use the same HSMs to integrate with all different solutions, including, and we have 400 different integrations with our HSMs. I've listed few as Palo Alto, F5, CyberArk, Citrix, GlobalSign, Venafi, OpenSSL, and a lot of different Microsoft services that allows the use of our HSM. So this is exactly how we fit into your network. If you have the on-premise, you'd actually see something as a CCKM here. I have a couple of more slides to explain what are these. So BYOE is a bring your own key concept that is being supported by 3 major cloud providers or 4 major cloud providers. That includes AWS, Azure, Google, and Salesforce. So these cloud providers allow you, and even the IBM cloud as well. So all these allow you to use the native encryption that they are providing using the native tools. So for example, Amazon Redshift or the Amazon EBS, they provide you, these are the native tools. These are the cloud native tools. They allow you to encrypt them. However, using the BYOE concept or bring your own key concept, you can generate the keys in either our key manager or our HSM, and then you can import the keys into each of these platforms. This is good if you're using just one cloud platform, because each cloud has a completely different way of generating, exporting, importing keys onto the platform. So if you're working with multiple cloud, you can still use HSM or the key management platform for the generation storage of the keys. However, you have to create your own application servers that have the logic of generating the keys, importing, exporting the keys in and out of the cloud platform onto the HSMs. What do you do? So we support it. However, when you go towards more than one cloud platforms, it becomes harder for you. It also is, everything is manual. You hardly have any control on the keys that are you push into all these cloud platforms. So what do? You can actually use our CCKM platform. So CCKM platform supports all these different cloud providers. Everything is automated. So if you want to push a key into AWS, in Azure, in Google, you can literally, within a couple of clicks, it integrates with our HSMs, it integrates with our key manager. So you can generate a key, and with a little push of a button, you can push that key into AWS. If a time comes, if you have to delete a key from AWS just because you get a notice saying FBI or CIA wants to look into your data, and as an organization, AWS, Azure have to submit your data and the key, you have 1 week to respond. If you don't respond, if you don't act, or if you don't do anything, they have to submit your data and the key. This is where you can simply delete the key from CCKM, and the data can reside there forever. Just because it's encrypted data, no one can actually know what it is. So that facility is not available with the keys that you generate in AWS or Azure platform that you can get with the CCKM platform. Rotation of the keys automated. You can define the rotation of the keys as well. Above all, you can actually see which application is using which key. It's an amazing report, how many times a key has been used. So you have that kind of granularity when using the CCKM platform that you don't get with any other solution that you're using. And as I mentioned, it creates the key onto our HSMs and keep a copy of the key onto our HSMs or the key management platforms, so our super secure solution. Then, if you're using BYOK, you're definitely using the native encryptions. If you're using MYOK, so this is where, forgot to mention, this is manage your own key, so you can manage your own keys yourself. However, if you combine the CCKM platform with our own solutions that we discussed in the first slide, then you create the complete bring your own encryption solution, or the bring your own encryption platform. The way it works is, as I mentioned in the initial of the slide, when I started the slide, cloud providers want you to use native solutions so that they can actually tie you in. However, in some cases, you have to use native solutions just because everything that you were looking for is in native solution. It could be cheap, you get the performance, you cannot have any other solution working there in that short span of time, so you have to use native solutions. And we understand that. If you're using native solutions, you are forced to use native encryption. If you are forced to use native encryption, use it with CCKM platform that allows you to store the keys into a hardware, HSM, or a virtualized key manager, either way. So that means your keys are always secure. You have the complete control of the keys. You can always have a place to delete the keys, rotate the keys, renew the keys, and have all the different reports. However, you then have all different solutions where would you like to use not the native encryption, however, encryption that you have complete control on. So if you're using the solutions like data stacks, if you're using solutions like Oracle and MS SQL TDE, Oracle and MS SQL, or any other database for that matter, we help you in encrypting the data in all different places. As I mentioned, at the application level, at the database level, we have a world-class solution that helps you in protecting the data at the file and folder level. So if you are using more than one database, if you're using multiple databases, and you have a huge number of database server or a very small number of database servers, you can simply define that you will encrypt all the databases at file and folder level, or you're sharing or you're storing some organization secrets or some important information, critical information onto the files and folders and file shares or servers. You can simply encrypt all those using our file and folder level encryption as well, and then use the same solution to encrypt data stacks, encrypt on-premise virtual machines using VMware, on-premise vSAN using VMware. You can use the same solution to put an encryption on the applications using APIs, and then you can push this application in multi-cloud platforms as well. So with bring your own encryption, you get the complete control of your keys, of your security policies, of your encryption policies. You have a standardized way of encrypting the data and storing the keys and then managing the keys. And this is the last slide. These are the top 10 reasons to use or choose CipherTrust data security platform. One, it gives you the data discovery and protection in a single integrated platform. It can be deployed across multiple cloud platforms. It has a huge number of use cases, as I mentioned: file and folder level encryption, database encryption, application level encryption, storage level encryption, all of them others. It supports BYOK, MYOK, BYOE capabilities. You can use APIs. There is a self-service licensing for better visibility, and it supports FIPS 140-2 level 3 hardwares as well, for either as a complete appliance or a root of trust. Multi-tenancy is supported, and you can monitor and access the behavior of the users, and we have a huge partner ecosystem to support all this. With that, I conclude my presentations, and I'm happy to answer any questions if you have one.
Great, thanks for that, Manoj. So we have got one or two questions during that presentation. If you do have any other questions, please do put them into the questions window now, and I will field them. But for now, the first question is, what is the difference between CipherTrust Key Manager and CipherTrust Data Security Platform?
So thank you, Michael. So the question is between the key manager and the platform. So the key manager is a device which is either virtualized or it's a hardware device itself. So it's a key management solution. You use the solution to store your keys, generate your keys, and the platform includes all the different solutions we have with the CipherTrust Key Manager. So using this key manager, you can encrypt the data at the application level, database level, file and folder level, hypervisor level, cloud level, all the different levels. So all these different solutions makes the entire platform. So the CipherTrust Data Security Platform includes the Data Security Key Manager and all the solutions that we support with it, or the connectors we call them.
Great. So then we've got one more question. So what is the difference between BYOK and HYOK?
Oh, yeah. So BYOK is bring your own key, and HYOK is host your own key. Very rarely any cloud provider provides the capabilities of HYOK, host or hold your own key. You can, they have been used interchangeably. BYOK is where you actually push your key. You generate your key on premise, and then you push your key onto the cloud. Host your own key or hold your own key simply means you generate the key on premise, it stays on premise, and you use the cloud services using the key that never leaves on premise. And they are all supported with the HSMs and the key manager platform.
That's great. Thank you for that. It seems that we don't have any more questions. So if there are any more questions after the webinar, please do not hesitate to email them to me at tellmemore@bytes.co.uk, or reach out to your Bytes account manager, and I'm sure they'll be able to answer questions for you. But anyway, thank you very much to everybody for joining this webinar, and thank you to Lawrence and Manoj for hosting for us. It's been very informative. So,
thanks so much. Bye.